Hi, Chris here from EDRMedeso. Welcome to today's 2-minute tip. Today I want to talk about the subject of nonlinear adaptive remeshing. So this is a technique that allows you to automatically remesh part or all of the geometry if the mesh becomes badly deformed during the solution. It's particularly useful for things like extrusion problems, or in this case a hyper-elasticity, a rubber problem, where the mesh gets badly distorted and we struggle to get a solution. So if we look at this particular problem, it's a fairly simple model. I've got a rubber cube and I've got a steel press. And if we look at the loading, I've got a displacement at the top of the steel press and I'm pushing it down into the rubber cube. It's a quarter model, so I've got two symmetry regions in here, and the bottom of the rubber I've applied a frictionless support. So a fairly simple model. And when we try to solve this, it hits problems. So if we look at the force convergence curve, we can see actually the solution only gets to about 82% of its pseudo finish time, which is 1 second. And we see it converges okay up to about 50% of the way through, and then struggles to converge and ultimately fails to achieve a solution. If we look at the model, you can see we've got considerably the way through pushing this press down into the rubber, but we can see the mesh has become badly distorted. So as I mentioned, one of the tools you have in Ansys to combat this sort of problem is nonlinear adaptive remeshing. So how do I implement that? So if we go down to the structural static branch and I do right mouse click insert, and we go down to nonlinear adaptive region, and I select the rubber block for the nonlinear adaptive region. So that's defining that only the rubber block will be potentially remeshed during the solution. I can then specify criteria. Now there are a number of different criteria: geometry, box, mesh. I'm going to use mesh in this case. So mesh is basically saying I want to look at the mesh quality in order to remesh. And the quality parameters I'm going to look at, I'm just going to select skewness. So this is basically saying when the element becomes skewed above a certain level, then it will look to remesh. And I'm going to put a level of 0.6 in here. The other things you can specify are things like time range, how often you check the element quality during the solution to mesh. So I'm going to put, I want it to check quite often, almost after every iteration. So I'm going to put a large number in here as 100. And time range, I know it converges okay to about 50% of the solution. So I'm going to ask it just to start checking for remeshing after 50%. So I've put in a time range for checking for element quality between 0.5 and 1 second. And we're sort of ready to go. So let's see if we fare any better with this solution using nonlinear adaptive region. First I need to actually activate the nonlinear adaptive region. Third time lucky, activated, and we'll click solve. So if we go down and look at the solution as it happens, we can see before the solution is converging early on quite easily. We're up to 30%, 40% through the solution now. We've reached 50% of the solution okay, and this is the point it starts checking to see if there's any skewness in that mesh. We've seen there's a bisection taken place. And now Ansys has done its first remesh. So this orange bar in the force convergence graph is telling us that it's done a remesh and it's continued the solution. At this point I'll just pause the recording and we'll come back in a couple of minutes when it's finished. Okay, welcome back. Here you can see we've got a solution. We've had a few remeshes through the solution, 1, 2, 3, 4, 5, 6, 7 remeshes, but we've got to 100%. So we've actually got a solution out of here. And let's have a look at the deformation plot. So we can see down here we've got a deformation plot. The first thing we notice, even at the end of the solution, the element quality is quite good. Let's just do an animation of these, just so we can see how the mesh changes throughout the solution. So as we go animate through the solution, you can see at various points the mesh is remeshed to maintain that good quality. Okay, that's using nonlinear adaptive meshing. Thank you for attending today's 2-minute tip.